Now let's finally get into really what's the definition of a mineral, right? All of these examples we've talked about, but really what are they? In order to be classified as a mineral, a substance has to be 5 things. That's naturally occurring, inorganic, solid, ordered internal structure, and a definite chemical composition. So let's go through with these one by one. Naturally occurring, that means that they have to be able to occur without humans making them. Right? That means that the garnet that forms naturally out in the world is a mineral. However, the garnet that we can make in a laboratory, that's not considered a mineral, right? Humans produced it. So even though it could chemically be the exact same thing, we no longer call it a mineral if it's made synthetically by humans. The next one is they have to be inorganic. This means that not only can minerals not be created by humans, they also can't be created by any other living thing. Right? So inorganic just means they cannot be formed as a result of biological chemical processes. They can't have any carbon in them that was formed by an organism. Now, there are tons of exceptions to this rule. I really don't even know why we have it as a rule. So for example, the mineral calcite is a part of mollusk shells, right? So it's part of clam shells, snail shells, oyster shells, right? All of those mollusks create calcite within their shell, and we do consider that a mineral. Likewise, our teeth and our bones that we produce as humans and all other animals produce has the mineral apatite in it. So we do actually produce the mineral apatite in our teeth and our bones, and even though we biologically produce it, it's still considered a mineral. So again, it is in general a rule, but there's a lot of exceptions to this inorganic piece. All right, the next one, and there's no exceptions to this one, is that minerals have to be a solid. So solid ice is a mineral if it's naturally formed. This means that natural glaciers, natural snow, all of those are minerals because they're naturally formed and solid. However, liquid water is not a mineral. So that means you take a glacier, which is a mineral, you let it melt into water, no longer a mineral. All right, next up, minerals have to have an ordered internal structure, meaning that if you were to zoom in and actually see each individual atom, each individual compound and bond between those atoms, it would all be in an ordered structure, right? The same shape repeated over and over and over and over again. For example, in this image, the crystalline quartz, SiO2, has that tetrahedron shape that's just repeated over and over and over and over again, constantly, always in this exact same pattern. On the other hand, amorphous glass could have the same chemical components, right? Could still be SiO2, but if those bonds aren't ordered, if sometimes they're at this angle, sometimes at this angle, and they just looks like they don't have any repeated shape, then that's not a mineral. So SiO2 quartz, repeated shape, is a mineral. SiO2 glass, amorphous, no defined shape, is not a mineral. Lastly, minerals have to have a definite chemical composition. That means that every single mineral, I can write down its chemical formula. I know exactly how many cations it has, meaning the ions with a positive charge, and anions it has, the negative charge, right? So quartz is always going to be SiO2, 1 silica per 2 oxygen, always, right? Some things don't have a definite chemical composition, right? Like amorphous glass can sometimes have, a variable number of silica, a variable number of oxygen. We don't consider that a mineral. Okay? Now, if something is all 5 of these things, naturally occurring, inorganic, solid, ordered internal structure, definite chemical composition, then we consider it a mineral. And minerals are important because not only do we use them as resources in our everyday life, they are what make up rocks. So if you ever really looked at a rock, you'll notice that many of them are speckles of different colors. For example, granite has a little bit of white, a little bit of clear, a little bit of pink, a little bit of black. All of those different colors are different minerals. So rocks are just aggregates of minerals.